Okay, let me bring up my notes, my cheat sheet, so I can take you through it. And for this one, what else? And another thing that I'm going to ask you is from now on till the end of the semester, when you're coming to my class, cell phones are gone. Okay? Your computers, be my guest, but cell phones go off the table. I don't want to see anybody's cell phone in their hand unless you're having a heart attack and calling 911. Okay, so make sure no cell phones in hand, please. Okay? I don't know, for some reason it's absolute turn off for me when I'm teaching and I see somebody's on a phone and doing something. That is really, really bad. So please don't do that. Okay. 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 Let me open what we've done last time, do a quick review. So I'm just going to go back one day. Just open it up. Any part you have any questions and you want me to stop and explain more, let me know and I'll stop and I'll explain more. Although I would love to be on time, on schedule, but your knowledge is more important than that. So as I mentioned, if I'm two weeks late at the end of the semester, then you're going to learn only 10 weeks of the material. I'm not going to cover it for the sake of covering it. I want you to understand. That's what's important, okay? And each class is different with the other one. So again, based on your feedback, we speed up or we slow down. Before we begin, I didn't talk, did I mention how to work on GitHub quickly, like a very quick thing with the arrows and circles and things like that? Everybody's looking at me as I'm a completely out of my mind type of a thing. Let me see if I can. Oh, that's. All right, so this is GitHub. I'm sorry, my handwriting sucks. Okay, GitHub. Okay, and you have your repo in here. So this is your GitHub repo. Okay, this happens only once on a computer. So essentially what you do, wow, this is kind of a surreal, three of me. All right, so the very first thing that you do is a clone. This happens only once, and only once, not 2 times, based on where you are copying where you are having your stuff. So this becomes your local repo. Okay? This is called upstream repo. You know why they call it upstream? See, fish go upstream to, it's like that, upstream, where everything is coming from. This is your local repo. So you do this. This is the first thing that you do. And you clone, and you only do it once. Not twice, not 3 times, only once. Based on computer. So if it's on matrix, clone once on matrix. If on your computer, clone once over there on your computer. So this is the process of starting to work. This is how you start working. You come to your computer and you want to start working. The very first thing that you do is a pull. That's number one. You pull. Number one, you do a pull, and actually, that's wrong. You do a pull. 1, okay? After you do pull, then you start working on your stuff. How do you work? You can add. You can remove only by git, which means you cannot delete the files using your operating system. Anything you do, it has to be using git. If you are on matrix, you have to say git rm for removing something. Okay? Git rename, for git move to rename something. If you are on Windows, you have, or the same thing, Mac or Matrix. If you are on Windows, then you have to go on tortoise git rename, tortoise git delete, and so on and so forth. So, and modify. When is modify? Modify is programming. So whatever you do, you're programming, adding code to this and that and stuff like that, and suddenly say, I have to go to washroom, right? That all comes together to a commit and goes here. And this happens over and over and over and over and over. When you're done, you want to close down your computer and go. So this is number 2. That repeats 500 times. Then, when you're done, you want to close down your computer, you do push. And you're done. Tomorrow, when you are working again, you do a pull. Okay? So, if you look at it, my push all command and that I asked you to create on matrix, and tortoise git also has commit and push. So you can also commit and push at the same time. There's no problem. So you can do push over and over. There's no problem if you have access to internet. So number of pushes, no problem. The most important thing is pull before everything. But keep pushing, push, 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 and you're done. Okay? If you want to submit your work, what do? You go on matrix, you do a pull, and then you submit. That's it. So there is no file transfer anymore. You don't have any file transfer to, and that's it. That's the whole process of the thing that is happening. We good? Questions? Suggestions? Objections? Okay. Can I move this thing around? Yes, I can. So I can stop this. There we go. Okay. Good. So now we know. Last day, we talked. Did I open someone else's thing? Or did I create this in OOP345 NBB? Or I wrote that thing wrong. Open folder in File Explorer. No, it's B. Okay, so my apologies. That's NBB. Okay, and I don't know which day it was, but whatever it is. Anyway, so we talked about command line arguments, and we said the real syntax of main is with an argc and argv. Argc is the number of things on a command line, number of tokens on a command line. Argv is an array of C strings that holds all the values in there, and like that you can access every individual thing that you have on a command line. They're all strings. You cannot read integers. You cannot do stuff like that. If you're receiving a number, that number is going to be in string. You have to convert it to an integer any way you want. Oh, where's, oh, did I close the wrong thing? What's wrong with me today? Did I close the wrong thing? No, it's the same thing. Copy command we have done. OK. Environment variables. We said the third one over here is the environment variables that is received. So essentially, anything that you have in your operating system is set in here. The environment variable format that you are receiving is like this. So each C string that you're receiving in that null-terminated array of strings is as OS variable equals to OS value. So if you want to extract the stuff, you have to split it in where the assignment is. Whatever is at left is the name, and the right is the value. Yes?
I've looked it up, and you can use std get env instead of that, and then put in.
Oh, yeah, that's a completely different thing. That's a function that you can receive the stuff with.
Yeah, but it's easier than splitting.
I know. I want you to do it hard way. You need to be able to do all these things. I know what you're saying. Yeah, get VMB, that's absolutely right. So the function get VMB in standard library.h, what it does, if you put the value, it's going to give you the environment variable. Yeah, that's right. OK. We talked about size of an alignment, and we said that each entity in your program, it has a size. If you do a size of, it's essentially the amount of memory that it occupies in memory. And we said each fundamental value must sit in an address that is divisible by its size. It cannot sit anywhere in memory, and because of that comes the story of alignment, which means each compound type is aligned in a specific way, so all its properties, all its attributes are sitting at the proper line. That's why it's always better to align all your attributes from the largest size to the smallest size into the memory. We talked about void pointers, and we said void pointers are essentially pure value, pure address, and you can put any address in a void pointer, but you cannot put a void pointer in any address. You have to cast it back. Okay? We said we can use that for many different things. One good example for it was hexadecimal dump of a piece of memory. That was the example that we have done over there. We talked about references. And we talked about L value and R value. We said anything standing at left side of an assignment operator is an L value. Anything standing at right side of an assignment operator has a potential to be R value. You can have an L value at right too. L values can sit anywhere, but R values only at right side. The example for an R value is 10. 10 only sits at right. It cannot sit at left. We good? We're OK? The example for a reference that grabs only R values is 2 ampersands. If you put 2 ampersands after int, that int becomes R value reference, and therefore it picks up only the things that are either right value or temporary objects that are about to die. Only those can be going to those. We said we can force an L value to be caught by an R value reference, and that's using move in utility.h. If you put move around any type of L value, it will impersonate itself as an R value. We talked about range-based loops. We said that any in C++, you can create a variable inside a for loop. We call that, I don't think I mentioned this, that is called an iterator. By the way, I talked a lot, and for some reason, my tongue doesn't work properly in my mouth. If you hear me talking in a strange way, that's the reason. I have to keep drinking water. All right, as I was saying, that iterator iterates through the collection that you have over there that happens to be an array in this case. So essentially, in every loop that you have, that iterator, that element that we have over here, will get the values of each element of the array throughout the loop. If the iterator is value, then the value of each element will actually get copied into it. But if you set it to a reference, you can actually change and modify each element using the iterator. And we explain it with this one. So if you actually put a reference over here, we can set everything to 0. Iterators need, this range-based loop needs to know what the size of the array is. Because of that fact, built-in types, a built-in array. What was a built-in? Remember, built-in values? Concept question for midterm? Wraps around fundamental types. So any built-in type that you have only knows the size within the scope, which means your array over here that is A, its size is only known in main. If you pass the array to a function, you have no access to its size anymore. Got it? So range-based loop only works in the same scope. You cannot use it somewhere else, unless the collection that you have is not a built-in type and it's one of the standard template library location collections like vector, array, queue, dequeue, list, stack, things like that that we have in standard template library that we're going to learn soon. All those things can actually range-based loop works for them. Array initializations, we said that we can use the, when you're doing array initialization, you'll mention the size, it gets the size. If you mention the size and you have less values, the rest will be defaulted. If you don't put anything because of that one, everything's going to be defaulted. And that's how array initializations work. We talked about classes. We said classes are encapsulation of data and behavior. I mentioned it with a very simple thing. And then we talked about class initialization. And we said initialization in the class happens in 2 different places. One, default initialization, what we have for the attributes. If you go back to ancient C++ compilers, those things don't work. Those are actually relatively new, the initialization inside the class. Okay? And then we have the member list initialization that kind of overrides that one if it exists. If it doesn't exist, the initialization happen. If it does exist, those things won't run. So for example, name over here will be set to an N and not empty over there. And we had to remind you that the sequence in which you are initializing in a member list, that sequence should be the same as the sequence of the attributes you have in an item. Certain compilers give you warning on that. And then we talked about moving. We said move we can use that R value. We can use that R value. We can use that R value reference to our advantage to detect if a class is being moved or it's just a regular copy. When a class is about to die, it is stupid to copy everything that it has. We can just take over whatever it's about to lose and let it go by itself, and we take its properties. Like that, everything's going to go faster. Okay? If you want to take my notes, if I don't want them anymore, I can give you my notes, and it takes 3 seconds. But if I want my notes, then you have to copy it. It takes time for you to write it. It takes much more time. Okay? Copying takes time, passing by. Okay, so we can detect if Farhad is supposed to die, so we can take his notes, he's not going to mind. But if I'm not going to die, I'm going to need my notes, right? Good? Everybody's happy. He's going to die. Okay, so next. Okay, so let's see what we do. So we created a set to make our life easy. So set essentially does the dynamic memory allocation and stuff in a safe way for us. I'm going to hide it. Then we said we can create the class that we have using dynamic memory allocation. And the destructor is common with rule of 5 and 3, so it's there at the beginning. We created a copy constructor. With our copy constructor, we had to do dynamic memory allocation. But when we are doing move constructor, move copy. Move constructor, when we do move constructor, what we do, instead of copying everything, I'm going to say, I'm going to point at your information and then make you not point at it anymore. Therefore, I have your information and you're gone. As simple as that. And we did the exact same thing with move assignment. I don't know why I didn't comment this. We do the same thing, exact same thing with move assignment. So we said, if it's being moved, if what we are having over there is either a temporary one or it's being moved, I can actually say, I'm going to take over your stuff and you're not going to take over it anymore. Therefore, I own it and we are passed through. There is another way of moving stuff too. So I can say over here N1, N2, that I have over here is equal to move N1. Remember that. So although N1 is in here, if I move after this, the M1 is going to be empty. That's moving, okay? That I'm going to go through it soon. So not necessarily an object has to die to move it. If your logic dictates that this object has the value, and I have the value over here, and I need the value over here, and the previous object doesn't need it, you can force it to move instead of copy. If you don't do it, so here it's got to be move assignment, but if I remove the move, it's got to be copy assignment. You got to make sure that you do the thing properly. And that was the end of what we talked about. Questions? Hello. Smoking or non-smoking? I'm joking. Take a seat. Okay. Questions? Suggestions? Yeah, go ahead. Quiz? No, we're not going to have quiz today. I specifically didn't mention so everybody comes in. But anyways, next, were you here earlier when I said we're going to have a quiz next week? Okay, so let's do it again. Next week, we have a quiz. I'm going to tell you a few days before what the question is going to be, so you know what the question is, and you're going to come do it in class.
Monday or Thursday?
It's always on a computer. I never do anything on paper. I haven't done it for 15 years. No paper for me. Everything's on a computer.
So during lab?
Pardon me?
So during lab?
During lab, and you have to go through the agreement and sign it. Otherwise, you won't be able to see it. So there's an announcement. You got the announcement, right? That you have to sign that agreement thingy. You did?
Yes.
What's going on?
It's like the quiz 0 now?
No, let me check. Yeah, let me check. Give me a second. Give me a second. So we are section B, and action required, complete the practice and agreement. When you look at this, it says, under the quiz section of your subject, 2 items are now available, this and that. What to do? Read it per mission, then complete practice, yada, yada. You have 3 attempts. Deadline was 17th. If anybody haven't done it, you want me to extend it? Okay, so because if you don't do it, nothing's going to be available for you. So I'm gonna first edit this. Why it doesn't allow me to edit it? Okay, so I'm going to edit it. I'm going to make the due date. We're definitely not going to be able to finish today. Letting you know right now. So I'm going to make it 22nd. So Monday, I'll make it 23rd. Post again, so it's going to notify you. Then I'm going to go here. Now I'm going to change the due date to the 23rd. Let me see actually how many of you didn't do it. I can see it actually. Give me a second. Holy moly. 1, 2, 3, 4, 5, 6, 7. 7 people didn't do it. If you don't do it, you won't be able to do the quiz. I am editing and extending the due date to the 23rd. 11:59 p.m. Save. Change due date. Yes. All right. Okay, so that's that. You may have received feedback from me on your quiz, the one that you did for OOP345. If you have received the feedback, I told you that, right? I told you that before. Okay, okay. I mentioned that before. Yeah, okay. See, seriously, I'm losing my mind. Anyway, so we're good. So let's continue. Now, let's start with all right, so that's that. So our target hopefully is to be able to go through the classes and go through all different classes that we have and understand how they work. Then we're going to talk about inheritance and inclusion polymorphism. Then we're going to talk about the class templates, essentially parametric polymorphism. And at the end, we'll talk about composition, aggregations, and association. We'll understand what they are. The understanding of what they are is going to take 5 minutes. Code example is going to be the next day you're coming in. So, we talked about classes we know. We talked about initializations fine. All right, so I'm going to add one more thing over here in case we need to use it. So include. So that's a dash hello CPP. That kind of tells me which actually we were talking about. Okay. So copy versus move. Understanding copy versus move. So the other class actually asked me to walk through this step by step and see how it's done. So I'm going to bring their version because I expanded it so it can be easily shown how it works. So I'll borrow their code, NRA. This was the one. Okay. This is a very simple example for move, and this is something that probably you're going to get in a quiz or something. So I have a box, and the box has resources that is single integer. That's all it has. That is dynamic. So when I create a box, it creates a new integer and put the value in it. When I copy it, it creates a new integer, copies the content of the other data, target of, into here. But when it wants to move, the difference is that it gets the data from the other, sets the other data to null, therefore the other one doesn't have the access, and when it deletes it, it deletes it. So now we can actually see how things are being moved and copied. Do you want this to be walkthrough, or you want to do it yourself? Anybody wants this to be walkthrough? All right, good. So why don't you say something? Say, anybody's quiet. Okay, so walk. So this is how it's going to happen. So as I was mentioning in the class, this is the kindergarten version of it. Like the way I wrote it, it's how an OOP345 person writes it. After it's done, I'm going to put the other one to see how the exact code is being written by a 345 person. Okay? So now we are running it. So we are in main, box is getting created, and a new integer is created. Obviously, first it's going to go initialize the data because no initialization happened over here. Now data actually points to a 42. Are we okay with this? Okay, so it's created. Now we're going to come over here and do a copy. An assignment at the moment of creation is a call to a constructor. The constructor is receiving another object with the same type, therefore copy constructor. So copy constructor is called. Obviously, copy construction requires a new. Obviously, the copying happens. Initialization happens first, but it creates a new object and copies the content. Therefore, it is a copy of the other one. But in this case, we are going to say create an instance out of a new box C, but move A into it, which means it wants to copy A, but because I'm requesting move, that move is going to go to the move constructor. Therefore, instead of creating a new integer, it will say, I'm going to point to your integer. It's not pointing to anything. Now they are both pointing to 42. Now it's going to say, you don't need that anymore, so sets the other one to null. Therefore, the other one loses its 42. First one, B has 42, C has 42, A is empty. That's moving. Are we okay? We good? All right, so that's that. So move demo. When I say 244, I mean 244 skill set, where this is how 345 will do it. So what I'm going to do in here, I'm going to say, first of all, I don't need initialization. I'm going to say, when it's created, initialize the data with a new integer with V in it. Done. Initialization, dynamic memory, everything happening in one shot. I don't need to have anything in the body. Okay? Number two, copying. Initialize the data to new integer that copies the data of the other. Copy constructor done, one line. Nothing needed over there. Moving. Initialize the data to the address inside the other data. Then, now in here, I have to actually make the other one null. So other data is null, and that's it. That's the moving. It does the exact same thing as the other one, but more beautiful code. Are we good? So this is C, move demo. Oh, shoot. One more time. Don't save. What happened to my code? I think I pushed the wrong thing. Just one more time, sorry about that. Control S. So that's C, move demo pro. Okay, we'll ignore the other move. Now, we talked about statics, people. Remember that? We talked about statics. We said that if you create a function called foo, and in that function you create a static int var, and then initialize it, and you say var plus plus, and then you call foo, and then cout var, and then you said foo. If you did this, the variable that you have in here will have the scope of foo, which means it's only visible in foo, but its lifetime will be the lifetime of the executable. The first time that foo is called, 6 will be initiated. Line 6, therefore, variable will get created set to 0. And then after that, it's going to be going away. So each time it's called, it's going to actually add to the value of var as it's going through because it's static. Are we good? Are we OK? All right. Then we said you can use the static to enforce file scope, which means I can actually have over here static int must be file scope only is equal to 1, 2, 3. So what happens is that this must be file scope cannot be externed to be used in other translation units, in other modules. It is forced to only be available over here. You cannot extern it somewhere else. We good? OK. So these were the statics that we talked about. Let me delete the damn thing over here. It's like delete. OK. So D. Now, the static that we need to know now is a static that is a member of a class, which is going to make it's going to make things a little awkward. I'll tell you why. Take a look. Now, the counter is a class. It has a static integer count. When you write something like this, so let's say this one actually has a regular thing, integer attribute. OK? It has something like this. And it has a print function that actually shows. I'm trying to put all the possible things that we have. Now I'm going to write a diagram for you to see how things work. I'm going to draw something for you. So this is the instance. This color is the color of the instance of a counter. So let's say I have over here 3 counters. One counter here, another counter over here, and one over here. So I have total of 3 counters over here created, OK, instantiated, A, B, and C. If I do something like this, obviously it is going to have 3 attributes. So that's the color of an attribute. So that's attribute, and another attribute, and another attribute. Obviously, when it's created, it's going to have 3 different types of print, which is going to be this one. So it has a print function over here, and a print function over here, and a print function over here. Are we OK now to this point? But the problem is over here, when we are saying static in count, you are saying this is a static variable, therefore it has to get created only once. I cannot have two of it. Because it gets created once, the static thing that you see is only created once. It belongs to no one and it belongs to all. How? Every single class will have access to it with no problem. Are we okay with this? And because it's something that belongs to no one, you cannot instantiate it or initialize it in a counter. You cannot initialize it in a constructor because which one? I have 3 of them. Which one is supposed to actually initialize it? It doesn't make sense. Because of that, you have to have a separate initialization line written under the class outside of it. So you have to say int counter count is equal to 0. This line makes line 7 possible. So essentially, using that line that you have created over there, you actually set the value of this guy to 0. We good? Are we okay down to this point? Now, obviously, I have over here a function called getCount that has static over it, which means I'm telling this method is static too, which means getCount is a separate thing somewhere else too. And it's a function that belongs to all 3, like the other one. Because of this fact that it belongs to all 3, the class doesn't need to get even instantiated to call it. You can simply say cout counter get count. Use the class name with scope resolution to call the method because it is a class method, not an object method. All the attributes and methods you create are to be used in the objects of a class. When you make it a static, it doesn't belong to object anymore. It belongs to the class. Of course, you can use an object to call it. I can simply say over here something like this. And I'm going to change this code a tiny bit, if you don't mind. I'm going to write over here pointer b. And I'm going to set it to new counter. So I just made the other one dynamic, just to show you something. So I can actually say over here a dot cout, a dot get counter, get count. No problem with that. I can say cout, b get count. No problem with that. Now I can delete b, and I'll go cout again this time, counter, get count. So what is the purpose? What did I do over here? What does class do? This class simply counts the number of its instances. In the constructor, it adds 1 to the count. In the destructor, it reduces it by 1. So if I create 2 counters, the count will be 2. If I delete it, it becomes 1. So it can actually keep track of how many objects are created out of this one. OK? Later on in the subject, we're going to learn how to create singletons using static methods. A singleton is essentially a class who has only 1 instance. You cannot create 2 instances out of it. That's called a singleton. We'll find out how we can do it using a trick. OK? So now if I run this program of mine, oh, another thing, extremely important. As you see, my prints are accessing either they can access either the count or they can access get count. Each member of the class can access all the static variables and static methods. But a static method, if it wants to print the attribute, can it? The answer is no. Because you have one instance, one function over here that is static, and many objects, it doesn't know which attribute you're talking about. Therefore, static member functions cannot access non-static data or methods. In getCount, I cannot call print, but in print, I can call getCount. It's one-to-many relationship. Okay? Everybody can point to one person, but one person cannot point to everybody. Got it? Okay. So running this code, we'll see that this is going to happen. First, I have 0 because there is no instances created. Now I created 2 of them. Now it becomes 2. I can show it using the instance or the pointer, but when I delete one, now I have only 1. And when everything ends, obviously I don't have anything left anymore. And that's statics to the bone. Are we okay? All right, stop. Okay, so what do I do in here with CTE? Statics. Say I want to create a person over here. So I'm going to say person, okay, class person. And that class person has a name, first name and a last name. If I wanted to do object-oriented, what do? I go create a class name and make it first and last, and then in here I'm going to create an instance of class name, right? But what if I don't want to use name anywhere else? I just want the person to have a name. I don't want a class for it. So what you can do over here is this. You can literally create what we call it an anonymous class, which means I can write over here struct. Obviously, creating a class doesn't make sense in here, but the struct is a class. Now in here I can say string first and string last, and then in here I can say name or mname. By doing this, a person will have mname.first, mname.last without having any class name created. These are called anonymous classes. Are we okay? Right? So essentially, the type of mname is from line 6 to line 9. The whole thing is the type of the name. Okay? We actually used this in C a long time ago in a galaxy far, far away. So EF. So in C, we did this. Because in C, we had to, when we created the structure, we had to keep reusing struct to recreate it, right? We had struct employee, yada, yada, yada. To create an instance of employee, we had to say struct employee A, struct employee B. So in C language, we did this to kind of work around it. We said type def struct, then we wrote what we want, course. So course became the name of this nameless structure. Now after I could say course A, course B, course C. So that was the C version of an anonymous class. EFG anonymous structs in C.C. I'm not going to call it C++ because it's a C thingy. Okay? For some reason, class, I feel like school is boiling. I feel like I'm teaching in a sauna. I don't know why. It's very hot in the school. And it's putting everyone to sleep. So I would love to be able to have it like shoot a video of your faces. Everybody's like, is it? It is warm, right? I'm not imagining this. Everybody's like in deep, deep sleep. Anyways, so say I want to write a program that deals with weekdays. So I want to go weekday 1, 2, 3, and I go through Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and so on and so forth. Now, same thing outside. I thought it's kind of colder outside. I can leave the door open, but it's the same. Okay, so what they did in C to do something like this to make the program more readable. Like it's very difficult. Like weekday, I have to say integer weekday, week. Then you say if it's 0, it's Sunday. If it's 1, it's Monday. If it's 2, it's Tuesday. So to make the program readable, they created something called enumeration. So you could say enum weekday, let's call it, and you open a curly bracket. It goes Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So what it would do was first it creates a type called weekday. So you can say weekday W. And it creates 7 constant integers with values 0, 1, 2, 3, 4, 5, and 6. So literally, if you print mon, you will see 1. If you print Wednesday, wed, you will see 3. It literally does that. It makes the program easier, or programming easier, because it makes the programming more readable, because now you can say actually weekday W or D, sorry, and then you can write code, and then you can write code, and then you can say if D is equal to Thursday, then do whatever you are doing. I don't know. Whatever. Okay, it makes it more readable. Very good? Okay, that was C. The problem with this is that when you do something like that, then Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday actually become constants and that you cannot use anymore. It becomes reserved names, right? C++ said, we don't do that. We need everything to be in the scope of its own. So what C++ did, so this is, let me just, what the heck is this? So this is EFG, C enum. So what C++ did was this. It said, make this a class, okay? And all those become in a scope of weekday, which means now in here you have to say D if D is equal to weekday Thursday. Therefore, they're not going to be constant global stuff. Scoped enumeration, C++, regular enumeration, C. They both work in C++. We good? Okay? So we actually, one of the very first things that I have done in my life when I learned C language was this. I can't do it now because false and true are actually defined. But doing something like this, you're creating a type called Boolean, which false is 0 and true is 1. So we used to do that. But now it's part of the language. We good? All right. So, inclusion polymorphism, ladies and gents. NRA, I did it somewhere over here. I'm going to. A review, okay? And a trick that we use, the programmers use all the time. So I have a shape over here, right? Shape is, what is shape? What do you call, what kind of a class is shape? It's a base class. What type of base class? Abstract base class. What kind of abstract base class?
Pure.
What kind of, which means it is called? An abstract base class that only has pure virtual functions.
Interface.
An interface, thank you. So this is an interface. Shape is an interface over here, right? Then I have cube. Cube has length, and it says the volume is this. Forget about clone for now. And the other sphere says sphere is this, and that's how the volume of the sphere comes out. And we can do all these good stuff, okay? Now, shape says you need to create something called clone too. So abstract base classes usually have this. What clone does, it makes it possible in future, using the base pointer, I can make a copy of the class. Because when you think about it, if I have an array of shapes that are a mixture of cubes and spheres, if I get one of those shapes and I tell you, make a copy of this, how can you do that? You don't know what it is. It is impossible to know if it's a cube or a sphere. So you can't do anything. So what do? You force everybody to create a function called clone that returns a shape pointer. Then each descendant of that function, of that abstract base class, what it does, it creates a shape clone, and it creates a clone of itself. Because the latest version of the clone will be called whenever it's called, automatically the proper copy clone is done. So when I come down to, for example, display volume, when I receive a shape to display it, if I make a clone out of it, this S definitely will be the same type as what it was here, right? And if the shape is null, then it's null. Now, we'll go through the casting later on. And in here, when I display the volume, the volume, everything is displayed properly as we go through it. Now, upcasting. Can I cast a shape to a sphere? Do you remember what was that? So we had we had static cast, we had reinterpret cast, and we had what? Const cast, and then we had dynamic cast, right? Dynamic cast is an upcast, which essentially you can cast a parent to its child. What it does is that if I have these pointers, shapes like shape and shape 2, if I create a pointer of type cube, I can cast shape 2 to a cube. So I can actually deal with a cube. reference or Q pointer. The thing is that because you have no idea if it's really a cube or not, that cast may return null. So that's how you find out. If you typecast a parent to a child using dynamic casting, if the result that is returning is null, it means the cast wasn't correct. It wasn't a match. That's one way to find out. We good? Okay? All right. So that's that. E, F, G, H, I. How much time do we have? 5:05, right? Let me see how many things I have to cover. I explained Liskov substitution principle in the other class. Let me go through it quickly. You have to always do a correct inheritance based on what you have in real life. Sometimes this is not very clear. Sometimes when you are doing inheritance, stuff like this happens. You say, okay, what is a square? Square is a rectangle that the two sides are equal, right? Is that correct? If you go by that definition, your inheritance will be this. You want to have a rectangle. You say square is a rectangle. When you set the width, it sets both width and height. When you set the height, it both sets width and height again, correct? Right? So when you set a rectangle, if you have a function that's called set rectangle, okay, as a base class, right? And you set that to 3 and 4, and then you do or get with this and that, okay? Problem is that if you pass a square to it, it's not going to work anymore. If you pass a square to the set, when it goes, this one's going to set width and height to 3, this one's going to set width and height to 4. So you're going to end up with a square that has size of 4. So this design is not right. Why? Because for this to write the code, you should be aware if the R that you have is a rectangle or a square. It's not object-oriented anymore. Object-oriented means you should be able to use the object without knowing what it is in your inheritance. If I have proper set of inheritance, I should be able to use the base class and call its method, and through virtuality, everything's going to be called properly, right? With this, it's not going to work that way because it's designed incorrectly. The correct way is to always not only think about what happens when you actually, it's not only to see what you refer it in English, but to actually see if it makes sense. Now, if I create a square and I say rectangle is a square with a height, now everything is good. Because like this, I can set width and get width for both. And in here, I'm going to have a set height added to it. Therefore, when I actually go and set everything in my main, a rectangle could be a square. And regardless of what is the value when I'm setting, everything's going to be set properly. Nothing's going to go backwards and screw things up. This is a proper way of writing it. So again, when you are designing IJK, when you are designing, you should always think that if my children I called using the base, everything works properly? Am I narrowing down the base into the child? If you're narrowing it down, you're in trouble. Usually it should be widened. You follow what I'm saying? Base should be narrow, child should be wide. You have to add to the description of the child, of the base, to make a derived class. If you try to narrow down the base class in the child, usually you are going the wrong way. You're going to be in trouble. 37. Let's take a break, 5 minutes, and then we come back. I'm going to talk about class templates. But before that, I may talk about, anyways, you go and come back and we'll talk. I'll pause it. Please remind me to. All right. So first, what I'm going to do now, I'm going to teach this as if you guys know everything in OOP345 about templates and stuff. So I'm going to go through whatever is taught. So I'm going to just show you syntax. This is what I'm going to do. We're going to go through syntax. The next day you are coming in, I'm going to actually write you a template from scratch. So I'm going to actually create a template for you and show you how it's used. And so in practice, you can create a complete, I don't know if you can call it professional templates of your own. Okay? So for now, we're just talking syntax. Okay? First off, let's go through creating templates. So first of all, please, and this is not gonna, okay. So I am creating over here a template that swaps two values. And sadly, it's, let me just change this swap to capital S, because we have a swap already. It's kind of causing a conflict of name. So the swap that you see over here, and I'm going to comment when you create a template of a function, this is a review of OOP345. When you create a template of a function, essentially you're giving the blueprint of what needs to be written to the compiler. And you are creating placeholders to be replaced with what you desire when you are actually calling the function. When you create a function template, if the function calls don't exist, the result of the compilation is lack of that function. If a function template is not called, the code for it will not get generated and translated into binary. Therefore, your executable will cease to have any type of swap function in it. But as soon as you call the function, compiler looks at the function, through the signature understand that this is two double, so it knows the T over here needs to get changed to double. Therefore, a swap with double reference A and double reference B will get generated for you and compiled. Then it comes to line 21, and it sees you are doing the same thing with two longs. Therefore, it creates another function called swap with long reference as arguments. We good? Because of this fact that it needs the whole logic to regenerate the code at compile time, templates cannot have a header file CPP file module. If you recall the compilation, each module gets compiled separately without being aware that another module exists. if you create a template of a function template with a prototype in header file and the body in a CPP file, when the compiler is compiling, all it sees is the prototype. It doesn't know how to create the body. Therefore, your function is not generated. Because of this fact, all templates need to exist in the header file only. There is no CPP file for a template module. A template module is only a header file. Do we understand this? It's all good? All right? Raise your hand if you're okay with this. Okay, the rest are sleeping. Okay, all right, so that's that. Now, when you create a template, say maximum thingy that I created over here. This is obvious that for any primitive type that I have, for any fundamental type, it works perfectly. Because for fundamental type, greater than sign is actually defined. So if I want to find the maximum between two numbers, that will work just fine for me. Let me actually do it this way. I'm going to So for line number 15, life is beautiful. It's going to actually create a maximum function that has a double A and a double B, and it can return which one is maximum. Are we good with this? Problem comes when it's doing maximum constant character pointer and constant character pointer. It doesn't know that it's not going to work. Actually, you're going to have constant character pointer A, constant character pointer B. Then it does what it's going to do. It's going to check the address of A being greater than address of B, which has nothing to do with the content of the two. So whichever is earlier in memory, that's going to be the smaller. Whichever is latest in memory, that's what's going to show up. So that sucks. It doesn't work. So what we can do over here is very simple. I can say, OK, templates are functions. What I can do is simply creating an overload. So I actually overload what I want to be done with constant character pointers using string compare. Are you OK with this? This will work perfectly. Absolutely no problem. Your program's going to work. But what is the purpose of a template? A template is created so the code is generated only if needed. The problem with this is that if you call maximum with constant character pointers or not, the code for the overload will get generated because it's a regular function. Are we OK with this? So although it works and it's an easier way to do it, it defies the whole purpose of templates. Therefore, we're not going to do this. We can very, very easily convert any type of overload to a specialization for a template. So instead of this overload, what I will do is this. I'm going to put the overload over here, and I'm going to say, hey, this is a special template, which means I'm not going to tell what is the type. How do I specify what type I want this thing to be used for? I put it right after the name. So I'm going to say, use this for constant character pointers. So what happens is that this is now a template that is only going to only get generated if constant character pointer is used for a template. Do I make sense? Specialization, overload. Efficient with respect to code generation for templates, easier to write. Choose your way. Okay? You can always, by the way, using the same concept, because it's kind of forcing it to use, you can always force different types of things. Like, for example, if I have an integer and a double, okay, so I have over here integer A is 1, 2, 3, and I have over here double D that is 4, 5, and I want to use these two with maximum. I want to actually say C out maximum A and B. Now, I don't know what is it going to do. Is it going to create maximum with 2 integers or maximum with 2 doubles? I'm not sure. You can always tell to the compiler which one to pick. You would say, I put this one, but I want you to use the double one. So you can literally tell to the compiler which one to pick. So it doesn't care if it's an integer and a double. It will create the double and call for this. Okay? Are we good? Function specialization. What did I do? Cancel. What did I do? Copy. Oh. Oh, D, not P. Oh, I have it already. Save, save, okay. Okay, so we can do the same thing for templates for classes. So essentially, if I want to have a class, I can actually class template, which means a class to get generated by the compiler whenever I want. I can actually do it. I can create template type name T and create an array and say, whenever they want to create an array of doubles, replace the T's with double. And voila, I'm going to have an array of class that works like an array. So essentially, if the T is double, I'm going to have double A50, double dummy, and the constructor is defaulted. Then I'm going to have double reference operator unsigned I. If it's smaller than 50, one of the elements is going to be passed. If it's greater than 50, the dummy is going to get returned. We good? So I can create this. There's a problem with this. So it actually works perfectly. You can actually use it. It's a class template. Okay? Again, don't forget, you cannot have the class and then the body in a CPP file. Everything has to be in a header file. But if I want to actually use this in main, I'll be in trouble. Why? Because if I want to create the array, I'm going to call it array, ARR. Classes don't have signatures. Functions, they have signatures. Because they have signatures, the compiler can pick whatever it wants, and it can generate it for us. Classes don't have that. Because classes don't have signature, I have to do the same thing that I did for the function when I want a specific thing to be called, which means for every single class, you have to mention what you want that class to be. So classes are always explicit. You have to say, what do you want? I want a class of longs, and then life is beautiful. You can do everything with the rest. So now the class can get created, and you can do whatever you want to do with it. That's a class template. OK? These are kindergarten stuff. I'm going to show you good class templates next day that you're coming in. Today is just a syntax, as I told you. When you are creating a class template, you can actually pass a second parameter for it. For example, for that array, you can pass a second parameter that is a non-template value. I can put the second one as an integer over here and say, put the integer for size. Doing so, when I actually want to instantiate that thing, I can simply tell what I want. I can write something like, let's do it like this. I can actually say over here something like array int 10. So now it's going to create an array of integers, TTTRL integer, and the size will be 10. Are we OK? We call this a non-template parameter. Non-type template parameter. So that's what it's called. I have 5 minutes. Bam. I think we're going to talk about those things afterwards. You can put default values for that one, but let me put it up. I'm not going to give you something. So for non-type template variables, you can actually put something like this over here. You can say equals to 100. So you can create an integer with 10, or you can create an array of doubles. So B will have a size of 100. And for static members, you have to specify which one you're creating. So the exact same signature of a template must be followed, which means if you have a static count and you want that count to actually get initialized, you have to template it. You have to say, this belongs to the template type name T, integer size, unsigned array T, yada, yada, scope resolution count. So if you are creating an array of doubles with size of 50, then the count for double with size of 50 will be 0 and nothing else's. Okay? So it creates a separate for each of them. Exact same thing that you have up there should follow, and you have to instantiate it exactly the same way. You have to specialize it exactly the same way. For inheritance, it's obvious. I don't need to, like, I'm putting it here, but you know, when you're dealing with inheritance, you just have to pass what you're passing to the base so it knows which one is inheriting from. That's all. So when you are creating the base needs to know which one it is. And the rest is the same. That's the syntax. So these are all syntax for inheritance. I have 3 minutes. In these 3 minutes, I'm going to explain this. So this one I'm going to say inheritance. House and a room. House and a room. Can I have a house without any rooms in it? No, a house is built up of its rooms. Okay, when you're walking in the street, can you see some, oh, look at that, a bedroom. Doesn't happen, right? A bedroom is always in a house. A house is built up of its rooms, and each room can only exist in a house. A house is built with the rooms in it. When you demolish it, the rooms go with it, right? That's called a composition. When an object is built up of its parts. Are we good? You're a member of a club, I don't know, hockey club. At the same time, you're a member of a book club. So a club is built up of its members, right? And if your club goes away, the members don't die. They're still there, but they're not member of that club anymore. But a club is built up of its members. A club without a member doesn't make sense. This is called aggregation. It's a weaker composition. Composition owns its parts. When it dies, everything goes. When it's created, everything is created by that. Aggregation, no. Aggregation, although it's built up of it, but the members, the parts can exist. I'm a prof, you guys are students. If I die, you're still students. If I have no students, I'm still a professor. This is called association. The two objects are related with each other, but they have absolutely nothing to do with each other. How many professors you have? 5. How many students you have? 200. It's summer, I'm off, I have no students. I'm still a professor. It's summer, you're a student, you don't have any professors. Right? This is called association. Done. Lecture is done for today. Go read everything, okay? Read everything and come up with, come to the class with ready brain so I can actually give you examples of all these, okay? Have a good one. I cannot believe I put everything together like that. Give me a second, let me just save these things. Let me just push these stuff in the repository, and then we're going to go.